Hello everyone, this is Rahul Kumar, and today we are going to discuss a very important concept in physics called free body diagram. This free body diagram concept help in solving problem related to Newton's law. So what I am going to do is will solve these three different problems I have taken. So using free body diagram we'll solve these three problems. So what this is the first problem. What is this first problem is as you can see that there are two block of mass m1 and m2. They are kept on the smooth surface and an external force F is applied on the system and it is moving with some acceleration a. So we want to find out the acceleration with which the system is moving, and this block is pushing to this block. So there is a push between these two, so we want to calculate that force also. So this is the problem number one. So second, this is the problem number two. We have inclined plane here, and on which there is one block of mass m is kept, and it is slightly moving downward to the surface. So we want to find out acceleration with which this block is sliding down, and we also want to calculate the force which this inclined plane exerting on the block of mass m. This is the third problem. So this third problem is we have two masses here, and they are connected with one rope, and with the help of pulley this system is moving with acceleration a downward. So what we will do is we will try to solve these three problem using free body diagram. So for understanding free body diagram, let's see. There is one I will use first illustration here. Suppose this is some kind of lift here, and this is moving upward with acceleration a0, and we have one block of mass m, and this is connected to some weight reading machine. It has scaling, and it will read. So this is the weight reading machine. So obviously obviously this will read the how much total force acting on this total downward force acting on the this block. So we'll calculate with the help of free body diagram. So we'll draw the free body diagram of the block. This is this is the block free body of diagram. So obviously we have a tension here for with which this is hanging with the weight reading machine. So this is the tension, and this is the downward force, its weight. So this is mg, and the whole system is moving with acceleration a0. So applying Newton's second law, we see that this is T minus mg equals to m a0. So here T is equals to m a0 plus mg. So we can see that this is somewhat this reading, this value of T. Our machine will read this value of T. So our machine will show that the weight of the object, this block, is not mg, it is mg plus a0. So the weight is increased here in this case. So this is the first illustration. You can see that what I did was I just focused only on the one object, and what are the external forces acting on it. Analyzing those forces, I was able to solve this problem. So this is how we solve the problem using free body diagram. So I would like to take another illustration here. This is the second illustration. Suppose this is a table here, and this is the table of mass capital M, and one book is a small mass m, small m, is kept on the table. So we want to know that why this book is not falling down, or this table is not falling down, even the force of gravity is acting downward towards it. So so what Newton's second law tells is that So using Newton's second law, we will solve this problem. So we will first draw the free body diagram of book. So free body diagram, both the things we will draw for the table. This is the table. This is the table of mass m, and this is the book of mass small m. So we have drawn the free body diagram here. So what are the forces acting on the book? So obviously it has a weight acting on it. So its weight is mg due to the gravitational pull, and there is one normal force by the surface of table, because it shouldn't move. It is staying at the table, right? It is not moving downward. So according to second law, there if according to second law of Newton's, so this object should move towards downward, but it is not moving, which means that there is some normal force acting to the block. So that is why this is the normal force. We usually represent it with n. So this n is equals to mg. So now we see that why this book is not uh, moving. It is just staying on the table. So now we'll see about the table. So what are the forces acting on it? So there is one weight. So weight of the this weight will exert this weight is exerted on the earth. So this force this weight will be weight of the table itself, and weight of the mass also, weight of the book also. So the mass of the so the weight of the weight acting on the table should be at small s small m plus capital M into g, and normal force should be n dash, because it is not moving. So this normal force is exerted by surface of earth. This earth surface is acting, because according to Newton's second law, the object must move towards the must accelerate towards the net force exerting on it. So it is not moving, which means that external force is net external force is 0. So this n dash minus m plus a small m into g should be equals to into g should be equals to 0. That is why, that is what n dash equals to a small capital M plus a small m into g. So this is the normal, these two are the normal force, because of which they are not moving downward. They are still at its original position. So this is the second illustration using a free body diagram. We were able to analyze the situation, why it is not moving downward, why it is not falling. So this is the second illustration. A third illustration I would like to discuss here is it is not much related to what usually we have in Newton's law problem. So here we have many students got a misconception here, why it is happening. So we have here two circular path, and one at the peak we have one apple here, and it was somewhat hold by something, and there is one vehicle here which is moving with some velocity v. So immediately after we leave the apple, this will fall down, because of gravity. So this will fall down the surface on the circular path, but this doesn't move, this doesn't fall. It will continue, it continuously move around the circular path. Why it is happening? Because see here where the velocity was 0, so that is why the net acceleration was towards the center, so it fell down on the surface of the circular path. But this for this case the velocity at the peak is not 0. So obviously there is one force acting on it. So this is the gravitational force. We can also say that it is the centripetal force mv square upon r, where r is the radius of the circular path. So because of this force there will be change in the velocity. So here you see that this is the velocity v with which the object is moving, and this is the velocity small change in velocity because of this centripetal force. So the net velocity will be this is the net velocity we will have. So this vehicle will move towards tangent to this circular path, so it will keep moving tangential in the tangential direction to the circle. That is why it will keep moving and moving. So now, that is what I wanted to tell about the free body diagram. I think you have now some idea about free body diagram. Free body diagram is we have various objects in the system. We just identify our one object at a time, and we see that how many external forces are acting on it, keeping it free from the other other objects. So now we analyze the system, what are the forces acting on it, and based on applying Newton's law, we solve the problem. So here what I am going to do is here I am going to solve problem. So we had problem number 1. So what was the problem? Problem number 1 was we had two block of mass capital M1 and M2. We had two mass. They were connected with each other. They were in close contact with each other. They were kept on the smooth surface. So which means that there is no friction between the surface of a block and the this smooth surface on which it is kept, and there was one external force F applied on the object. Since net external force is applied towards right, this will accelerate towards right. So according to second law, so we want to find the acceleration A, and we also like to know how much force this M1 is exerting on M2, and M2 also is exerting M1 according to third law. So we will first draw the free body diagram of M1 and then M2. This is the free body diagram of M1 and this is M2. So what is happening here is there are two vertical forces acting on it. One is its weight, so its weight is m1g, and another is the normal force applied by the surface on which it is kept. This is the normal force n1. So and another horizontal direction force is acting on it. This is the capital F, and since this is pulling this mass m2, so in return, according to third law, this m2 will also apply the same suppose this m1 is pushing the m2 with the force n. Obviously this is the normal force because it is exerting along the perpendicular direction to the surface. So this is the normal force. So according to third law, the same force in the opposite direction will be acted upon. So here on the m1, and this whole system is moving with same acceleration A. Now we want to find the acceleration of these two blocks. So for vertical direction, we see that n1 here, n1 is so here n1 is m1g, and this f minus n is equals to m1a. And here I forgot to mention here two vertical forces. What are the vertical forces acting on it? There is one weight m2g and one normal force n2 acting on it. Because of it, it is staying on the surface. So again we will apply Newton's second law. We will get n2 equals to m2g, and n is equals to m2a. So we have got four relation, and using these four relation we will find out the value of a and n. So first we will take these two, this two and fourth relation. So by considering first, second and fourth relation, we have f minus n equals to m1a, and n is m2a. So this is f minus n is equals to m2a. So f minus m2a equals to m1a. So this implies that A should be equals to F upon m1 plus m2. So we got the value of acceleration A. So this is the acceleration with which this whole system will move towards right direction, and we also want to find the this push by the object block, so this n. So according to this fourth relation, we have n equals to m2a. So this n is equals to m2 into, so a is here f upon m1 plus m2. So now we got the value, n, this n is equals to m2 into f upon m1 plus m2, and a is equals to f upon m1 plus m2. So now using free body diagram we solve this. We found out the acceleration with which whole system is moving towards right, and the push they are exerting on each other. So now coming to the second problem, what was the second problem here? So second problem was, we had one inclined plane on which there was one block of mass m was kept, and it was sliding with some acceleration. And we wanted to find the acceleration of this block. So we'll try to draw the free body diagram for the mass m. So this is the plane, so this will exert a normal force on the, this is the plane, so this will exert a normal force on the block, and its weight will act on a downward direction. So this is mg. So now we so there are no force, obviously we are considering there is no, this is the smooth surface, so there is no friction. So so what are the responsible forces in moving this block, we want to find out. So for that we will have to resolve this force. So for that we will draw a coordinate system here. So this was the theta inclination, and this was the weight mg, and this was the Newton normal force, which was n. So and so now we will resolve this. So this is obviously theta, because this is 90, so 90 minus theta, so this is theta. So this will be mg downward, mg cos theta, and this will be downward mg sin theta. So now we will apply this system to we will apply Newton's second law, and according to that, net external force along x-axis is equals to 0, and net external force and it is this is the x-axis, so this should be ma. So and according to y, this should be equals to 0. So what are the forces acting along x-axis? This is the mg sin theta, that is the only force acting. So this is the ma. So got cancelled, and we get a equals to g sin theta. So we found out the value of a, and here this fy is equals to 0. So n is upward direction and it is in downward direction, mg cos theta, this they are balancing each other. So this n equals to mg cos theta. So now you can see that we have found out the acceleration with which this block is sliding. This a is g sin theta, and the force this inclined plane is exerting on the block. So we got this using the free body diagram. So how handy this is, free body diagram. And the last problem I am going to discuss. What was the last problem? This is very interesting. So it was hinged, and one pulley was there, and two masses m2 and m1 was attached with some rope, and it was moving with some acceleration a. We wanted to find out the acceleration with which this system is moving, and also tension in the rope. So we will draw the free body diagram for m2 and m1. So for m2, what are the forces acting on it? Obviously this is the tension T, and this is the weight. So weight is m2 m2g, this is the weight. So only these two forces, and this system is moving with acceleration a, and here this is m1, and obviously downward weight is m1g, and tension is t. So this is also moving with acceleration a. So applying Newton second law, so Fy should be equals to m2a. So this is t minus m2g equals to m2a. This is the upward direction. So I have taken positive, downward I have taken negative, upward I have taken positive. So here also applying the same thing. Fy equals to sigma Fy should be equals to m1a. So here it should be t minus m1g equals to m1a. So we got two equation here. By solving these two equation, we will find out the value of t and a. So here what we will do is we will subtract second from 1. So subtracting second from 1, we will get m1g minus m2g equals to m2a minus m1a. So this a will get m1 minus m2. Sorry, here I made the mistake here. This is moving downward, so this is minus m1a. So this is minus m1a. So by subtracting it, this will become plus. So this is m1 minus m2 g upon m1 plus m2. So we found out the acceleration with which this system is moving downward, and we want to find the tension. So what is tension here? So we after applying this value a into the here, after putting value of acceleration a in any two of equation, we'll get the tension. So I leave it this to you how you put it, and I just write down the solution. So this will be, I think this will be m1 m2 upon 2 m1 m1 m2 upon this should be 2 m1 m2 upon, yes, 2 m1 m2 upon m1 plus m2. So that's it. Using free body diagram, I solved 3 problems here. You can see how handy it was with by using free body diagram. We were able to solve the problem. So I hope you understood the concept, and I was able to convey what I was intended, means what I wanted to tell you. Thank you.